material. Okay, so this magnetic particle testing we are doing only for ferromagnetic materials. Why? Because magnetic particle testing, the principle is based on magnet. Whenever you are applying current to any ferromagnetic material, the job becomes magnet, means it will act as north and south pole, and if there is any discontinuity, then it will act as north south, and again north south, means it will act as two magnet. Like if you broken one magnet, then you will get the two magnets. Similarly, it will act if there is any discontinuity, means there is formation of north and south pole, or we can say flux leakage or field leakage. And in this case, if you are applying iron particle, you will get the indication. So in magnetic particle testing, basically there are two types. One is visible, and second is fluorescent magnetic particle testing. So if you want more sensitivity, we are going to do for fluorescent magnetic particle testing. So, and also if you want the speed of inspection is high, then also our first choice is fluorescent magnetic particle testing. Okay, so based on sensitivity, based on speed, for automobile components, we are using fluorescent magnetic particle testing. And for example, weld and other joints, we are doing sometimes visible magnetic particle testing. So whenever you are doing visible magnetic particle testing, we have to ensure the light intensity should be greater than 1000 lux. And whenever you are doing fluorescent magnetic particle testing, the light intensity should be less than 21.5 lux in dark room, and ultraviolet light intensity should be greater than 1000 microwatt per centimeter square. So this is the requirement for magnetic particle testing, okay, regarding the light intensities. So, and based on magnetization, there are two types of magnetization. One is longitudinal magnetization, and second is circular magnetization. So this longitudinal magnetization we are doing with the help of yoke and coil. Okay, everybody knows the coil technique. The current is going circular and magnetic field will be longitudinal. Okay, so and for circular magnetic field, we are using central conductor and prods and headshot. So in headshot, we are sending directly current. In longitudinal direction, the field will be circular. So in central conductor also, we are using the same techniques. We are sending current through conductor in longitudinal direction, and the magnetic field will be in circular direction. So, and the prod also, there is, we are sending current and we are getting circular magnetic field. So these three are example of circular magnetic field. And also if you are sending current directly to the specimen, the technique is direct magnetization technique. Or if you are sending line of force to specimen, then it is indirect technique. Means here we are sending magnetic field to the specimen. Here we are not sending current to the specimen. If we are sending current to the specimen, and then then magnetic field will be high as compared to if you are sending magnetic field to the specimen. So these are the techniques. Then we saw the hysteresis loop. If you are increasing current, magnetic field will be increases, but it's true up to certain limit. After that limit, even if you are increasing field, if you are increasing current, there is no change in magnetic field. So that point is known as saturation point. Means what? In above saturation point, if you are trying to magnetize the component, even if you are increasing current, there is no change in magnetic field. So that is the saturation point. And hysteresis loops is generated only in AC current, because in AC we have positive cycle also, we have negative cycle also. Because of this positive cycle, negative cycle, your magnetic field also shifted from positive to negative. Means positive, then no current, then negative, then no current, then positive. So that's why we are getting hysteresis loop. So hysteresis loop is a graphical representation between your current and magnetic field, or we can say it's a graphical representation between magnetizing force versus flux density. So you know the flux density means the number of line of force per unit area. And what is magnetic field? Magnetic field means the total number of line of force. So total number of line of force is very difficult for measuring without breakage of magnet. So here Gauss meter we are using as a flux density. So so in particular area, how much magnetic flux density is there. So we are generally 10 Gauss, 15 Gauss, 20 Gauss. we 50 Gauss we will get the reading. Also we saw the continuous method and residual method. So in continuous method, the field while you are applying current means what we are doing first, we are cleaning the component, we are cleaning the component. After that, we are applying the bath on the component and immediately we are on the current. Okay, that means what? When current is flowing and at the same time magnetic ink on the surface. And then first we will stop the bath and then we will stop the current. If suppose if you are stopping current first, then there are chances to wash the weak indication. So the sequence of operation for continuous method is first clean the component, then apply the iron particles or we can say bath on the job specimen. You wet the entire bath, you wet the entire job so examination surface with bath and then you apply the current. Okay, and stop the bath and stop the current. So this is the process for continuous method. So continuous method is more sensitive as compared to residual method because in continuous method we are applying iron particle while current is flowing. Means your iron particles is present on the job while current is flowing. So in the residual method, we are applying current and we are removing current and then some of the residual fields in the examination in the specimen and then we are applying iron particles. So here the residual field is always weaker than original field. So the sensitivity will be less, but in sometimes if you have doubt about the indication, then we are using these residual methods to verify the our judgment. Okay, so also we saw the weight method, dry method. In weight method, which one is more sensitive? Weight method, because weight and if you are using AC current, then it's good for surface discontinuities. If you are using HWDC current, then it's good for surface and near surface discontinuities. So regarding the sensitivity, then we can say weight continuous fluorescent AC current is the best method to detect the fatigue cracks. Because at the initial stage of fatigue crack, the size of cracks are very small. So to detect that crack, we have to use weight method, weight continuous AC fluorescent method, because fluorescent is more sensitive. AC is good for surface detection because a fatigue crack always start from surface, and weight method is good for because we will apply the particles uniformly on the surface and the size of particles are very small, so it's good for small defects. Then we saw demagnetization. In demagnetization, after testing, we are removing the magnetic field, that is known as demagnetization. So also we saw the centrifuge test, settling test or concentration test. For fluorescent method, the settling volume should be 0.1 to 0.4 ml. And how we are doing this one? Just we are taking 100 ml bath from in centrifuge from your main bath and we are waiting for 30 minutes. After 30 minutes, the concentration, the iron particle will settle down at the bottom of the centrifuge and there is marking. Okay, and we are reading that one just 1.1, 0.2, 0.3. So in this way we are measuring the settling test means concentration. In case of visible magnetic particle testing means color contrast means regular magnetic particle testing, the concentration should be 1.2 to 2.4 ml for 100 ml. But for fluorescent magnetic particle testing, it should be 0.1 to 0.4 ml for 100 ml concentration of bath. So fluorescent, your indication color will be yellow green, and for visible, your color may be red, may be black. It depends upon your job surface because we are using the powder which will make the surface contrast more. So based on that, we are selecting the color of the particle. So sensitivity is not depends on color of particle, but the contrast depends on color of particles. So based on our job requirement, we are changing the color of magnetic particle testing. Basically, there are red, black. These two colors are common. Okay, then next what we saw, true indications, false indication, non-relevant indication. So true indication means the indication actually from the discontinuity. False indication means powder accumulated. Okay, iron particle accumulated because of gravity, because of rough surface, that is the false indication. And the non-relevant indication means if you are applying excess current, then there are chances of leakage field and you will get the indications. If your job having different permeability within throughout the lane, means at one place's permeability value is different from other area, and then in that case you will get the indication, because change in permeability within the specimen means resistance to line of force will be different, and there are chances to come out to some of the line of force, and we will get the indication. Also, if job geometry, because of job geometry also we are getting sometimes non-relevant indication. Then we saw what is part of the remaining. I think all we covered in this lab, small topics. So now we'll see the part how to do magnetic particle testing as per ASME section 5 article 7. So all ASME section 5 they gave the different articles. In article 7 for magnetic particle testing, article 6 how to do liquid penetrant testing, article 2 how to do radiography testing, article 4 5 for ultrasonic testing. There is each article different articles for different methods, and this article will provide us guidelines to develop the procedure, and we as a level 2 we have to work as per procedure, not as per articles, but for your study purpose we are going to see what's requirement for magnetic particle testing as per ASME section 5 article 7 we are going to see. So I hope so far no if anybody has any doubt, then please stop me and ask your queries, and once if you don't have any queries in theory, we will go for this article.
Yes, we can carry on.
कुणाला काही डाऊट आहे का?
No, sir.